go ahead and get started. So again, we're talking about file analysis and CDR, right? How do you put these two together to put together a formidable defense, right? Both technologies have strengths, both technologies have weaknesses, but however, combined in a seamless solution, can provide you an extremely powerful defense against both old attacks, new attacks, and previously unseen attacks. So I'd like to go ahead and introduce my co-presenters. And again, I'm always happy to be in a room with people who are a lot smarter than me because it always really benefit. I always benefit from that. So if you'd like to go ahead and introduce yourself, Ashley, please.
Sure. My name is Ashley Benj. I'm Director of Threat Intelligence at ReversingLabs, which means I get to lead a small team of very intelligent, really awesome malware analysis and threat researchers. My own background is primarily in the world of EDR. I've been in various different roles that have spanned across threat hunting, detection engineering, things of that nature. Prior to joining cybersecurity, I was actually an astrophysicist, so did a strong pivot there maybe about a decade ago, and have been at ReversingLabs for several years now.
Thank you. And Connor, if you could go ahead and introduce yourself, please.
Sure, thanks, Stuart. My name is Connor Morley. I'm the Principal Malware Security Researcher at Glasswall. I previously had experience in threat hunting and security research, again, specializing in EDR. A lot of my time is, again, spent specializing in focusing on new and developing techniques that are used by malware operators and malicious actors, and how we can thwart those. So previously in an EDR concept, but now focusing on how this is applied to the CDR technology.
It's great to have you both here. It's, you definitely can tell we're in the deep end of the pool and, when coming to cybersecurity. So this is great. So we're going to go ahead and discuss a few things, and we'll just go ahead and go through the agenda really quickly. So again, understanding what is CDR, how CDR fits into a zero trust methodology, how Glasswall and ReversingLabs work together. And then we'll actually go into some depth in a real world example, the Earth Kasha, which was a recent attack. And it's interesting to me because, again, this is attacks that are new, but they're old. They include things that used to exist, but they're being used in a new way. And lots of different things that can be, examined here. So I'm going to go ahead and hand this over to Connor. And when you go ahead.
Brilliant. Thanks, Stuart. So first of all, we're just going to go quickly cover exactly who Glasswall are and equally what exactly CDR is in the context of security technology. Thank you. So Glasswall is one of the leading developers and innovators in the CDR, or Content Disarm and Reconstruction technology sector. We are partners with both public and private sector organizations. And as you can see, we're actually affiliated with people like the NSA and NIST and NATO. And we're actually mandated by several of these organizations in order to secure their security posture in relation to adherence to certain specifications and compliances as well. And next slide, please. Thanks. So Content Disarm and Reconstruction, or CDR, works on the principle of taking a document and breaking it down into constituent components, and then verifying or mitigating or removing content based on security policy. So we'll quickly just walk through what this means. So first of all, you have a file which is inspected, and as you said, we break this down into its constituent components based on the specification from the original vendor. These are then checked against that specification to make sure they are adherent to that specification and they are not malformed. Step 2 is rebuild. So this is where any component which is seen to be not aligned to specification or is considered to be corrupt or malformed is attempted to be repaired. So this is to put it back in line with the specification. If this is not possible because it is so severely malformed, the file may be rejected due to being non-compliant. Otherwise, it can be repaired, so we can actually create a valid file from a potentially malformed or corrupt file. The third stage is cleaning. So this is where we have the client policy. So this is where you actually have granular control over what elements or components of that file you want to allow or disallow based on your risk tolerance. So this is where the client actually has genuine control over what they want to permit into individual environments. Finally, we have the delivery where the cleaned file is returned to the user after it goes through a semantic check. So this is where we check the rebuilt and cleaned file's content against its original content to make sure they're semantically identical so that the information that's being divulged by that document from the original and the cleaned document is the same.
So Connor, when a file, I have a file at the beginning and I have a file at the end. Are they the same file or are they mostly the same file or how does that work?
Sure. So technically, from a very low level standpoint, they are going to be two different files because, again, it's going to go through this validation section and it may potentially have malformed sections that are transformed. And depending on the client's policy, there are going to be components that are removed. So if you were to hash the original file against the end file where you have these components which are potentially being removed, there's obviously going to be a difference. So technically, it is a new file, but the semantic check ensures that the informational integrity of that document remains the same.
So in one way, it's like saying it's like a photocopy of an original, but
Exactly.
it's an exact copy. It's not been altered in any way,
Exactly. So at a face value, it's the same, but it will be the underlying components which will potentially be different.
Okay, thank you. So tell me about file analysis.
Sure. So one of the key differences between CDR and traditional file analysis technologies, especially when you're looking at file analysis and sandboxing, is that these can focus on, if we look at the old kill chain model, just to simplify this explanation, that file analysis and sandboxing can focus on delivery and exploitation simply because it can do analysis of files as they're coming into the system, but equally can look at the exploitation stage by, when it does sandboxing, look at the behavioral aspects of files as well. So you can actually see what it's going to do if it tries to perform some exploitative activity. CDR instead focuses primarily on the delivery stage. So if you, next slide, please. So CDR only focuses on delivery phase. So we only do a static analysis of that file. So we don't perform any behavioral analytics on what the file is going to do. We simply look at the components that are within that file and its structure and either clean the content or repair or reject the file based on its malformations accordingly.
Okay. So Ashley, when we talk about delivery and file analysis, I mean, these seem to be very overlapping. Is that correct?
Yeah, I would say so. I think more traditional file analysis and sandboxing platforms, you can look at the delivery vector. You can also look at actual payloads, things of that nature. I think the primary difference here is going to be where in the process you're looking to focus your attention. If you're an organization that has a much lower tolerance for any kind of lag or downtime, CDR is definitely the way to go.
Okay. So Connor?
Sure. So this slide is to demonstrate how CDR works in relation to domain security. So one of the high priorities for zero trust, for example, is the siloing of different components within a estate, because you have to assume that you're already compromised. So you want to silo different components within your estate and provide boundary security between the two. And the idea for this here is to represent risk tolerance based on these different domains. So moving from left to right, we can see that the CDR technology sits between the internet and public and sensitive and critical levels of risk tolerance. And equally at each stage, the CDR list of what actions are being performed on those files increases. So between the internet and the public sector, which has the highest risk tolerance, we could just be doing something like malformation filtering. So this actually boils down to the validating of individual segments and the rebuilding of files to see whether they're malformed or corrupt. So this is simply to make sure that the files coming into the estate are compliant with the specification and are not corrupt or malformed. Between public and sensitive, you may have additional security requirements where you could have external and internal links being removed, as well as active content being removed. Active content in this context is actually related to any component of a file that can perform independent action. So anything like acroforms or VBA scripts or anything to that effect at a very simple stage would be removed as part of this client-provided profile of what components can be removed based on active content. Finally, between sensitive and critical, you have additional things like embedded files, stack mitigation, and data loss. So embedded file removal, so any embedded images, any embedded video files, any embedded subdocuments like spreadsheets would automatically be removed, or would be put through the CDR process based on the client's preference. Stack mitigation is something which we've introduced, which is to do with covert communications within image files, primarily to begin with. So this works on disrupting hidden communication channels, which can be embedded into images for exfiltration or infiltration purposes. And data loss prevention is to do with certain redaction of terms within documents, which can be automatically performed during the CDR process. And as you can see, moving left to right, as you add these security capabilities, you are trading off potential utility as well. So active content, you wouldn't be able to perform low-level actions. And equally, as you go to critical, you wouldn't be able to have embedded images or embedded files or anything to that effect. So the document's utility, based on your security requirements, could be slowly traded off for a high level of security.
Yeah, when we were researching this and we were setting this up, this webinar, one of the things you mentioned was that you just don't do flattening. What is flattening, and why are you better than that?
So one of the things, so flattening is effectively a term where you convert a file into another file type, where you basically squish it down into a simple context, and you use that as a basis to either rebuild into the original, or you leave it in that flattened state. So effectively what you're doing is you're transferring a file into another simplified file context, which automatically removes a lot of those advanced capabilities. But Glasswall CDR doesn't do that. Instead, what we do is we actually reconstruct it in its original file context and don't perform any flattening whatsoever. So instead of relying on a translation to a simplified file format, we perform the CDR context in the original file context that the original file was in. So we don't perform any translation, we just do it in the format that it was to begin with.
Yeah, I was looking at some of the other companies that say, "Oh, we do CDR," and I was just like, it seems like they just save Word files as PDFs, and then consider
So
that, and we're done. And we have the same thing. We talk to a lot of people, and they're like, "Oh, yeah, you guys do file reputation. We do that too." And it's like, yeah, but we do it. We have 400 billion files. You have nothing. So it's a big difference. One issue here that I was thinking about is, we normally think in terms of like north, south, and east, west, right? So people, most people think about things coming into the network from the outside, but some of our largest customers use us for their own internal data lakes and their own air gap networks to monitor all the files that they're using for all their records or for all their building of their AI and things like that. So do you see a lot of people like your customers doing this on the inside?
So I won't comment on obviously how our clients do this on their internal structures, but it is something that, again, the zero trust ideology does, it does promote in order to do this. So again, these sectors inside demonstrated by this slide are to say these individual siloed domains, but equally you could potentially do this, as you've said, between different sectors of the organization or different users, depending on how you want to configure this sort of technology. Again, you look at how a lot of these compromises happen, where one business account is compromised and then that prolificates malware across an estate. Whereas if you had this sort of technology sitting between transfers between these accounts or individual online accounts, you could potentially have this in place as well.
Thank you. Go ahead and move on. Is that right?
Sure.
Whoops. And we're going to go the wrong one. Okay. So I'm going to go ahead and hand this over to Ashley. Thank you.
So let's go ahead and talk about ReversingLabs for a minute. Stuart mentioned we have a very large file repository, and that's true. We are a file analysis and sandbox platform, but outside of that, I think there are some key differences that make this a bit of a above and beyond sort of solution rather than what you may be more familiar with. And so we have this very large file repository. It's much larger than most of our competitors, and the file types that are supported are enormous. You have to be pretty obscure to not be within these supported file types, and that goes across all operating systems. And because we're able to work with all of these different file types and analyze lots of different files daily, we're also able to identify a huge amount of malware every day. Another one of the reasons that we're able to do this so quickly and effectively is because we're able to deconstruct these files and analyze them very quickly. And I would say that that's the key differentiator here, is that we're able to deconstruct these files and compare them to our file repository, what we've seen before, in a way that is a little bit different. We do this by hashing sections of the files versus comparing the entire thing. And so by doing so, we're really able to get very granular with all our analysis and identify very nuanced types of malware. If you could go to my next slide, Stuart. So like I mentioned, file analysis platform, but I would say there's sort of 3 tiers of the kinds of analysis that we do, starting from least complex to most complex. So first we have file reputation. And what this does is just very quickly and inexpensively check the file that you're looking at as an investigator against our existing database. We're looking to give it a disposition, just a simple good, bad. But we're able to do this, like I said, with a technology called ReversingLabs hashing algorithm, or RHA. And what that does is look at the file's features or behavior rather than any sort of particular file as a whole. And this allows us to compare the components that are within the file versus just a simple hash check or things along that line. So that's the static analysis, or the least complex version of ReversingLabs. If we get into something that is a little bit more complex, we also offer file enrichment. So this is everything from IP addresses or domains that a piece of malware might communicate with, either for command control or data exfiltration or some other purpose. Same with URLs. We can also give you detailed information on what type of malware, the activity that it has conducted before, threat actors, different types of files that might be similar, behavioral information, things along those lines. And then finally, the most complex option, sort of the object of last resort, is our sandboxing. And so our sandbox is able to really rip apart and deconstruct these very complex files, particularly very large files, in order to get that verdict and check against our file database. Usually, this is obviously an expensive process, and so we're trying to keep this as a last resort, as I said, and so less than 1% of our files typically need sandboxing. And so the goal here is to really go from least to most complex, least to most expensive, and try and save our customers as much time as possible.
Yeah, time and money, right?
Right.
And I think, a lot of people who've never worked in a SOC or a security organization don't understand how time is such a big issue. This file came in, it needs to be, we have customers who deal with contracts and work in convention centers and things like that. And they get all these contracts come in. They all have to be examined, but in the meantime, they're not doing business. They're out. They need to get this done. So, being able to release a file within a few minutes is a big difference than releasing it within 24 hours or something like that. So it makes a big difference to our customers, and also the quality of the checking to be able to do that. Okay, so talking about Glasswall and ReversingLabs. So Connor, if you could take over, please.
Sure. So Glasswall Hello is the product where we've got ReversingLabs and Glasswall CDR and ReversingLabs file reputation technologies put together to make this formidable defense technology. So CDR is comprehensive zero trust over the 38 file types that we support, with additional compliant types of 46 types. With ReversingLabs, file reputation and multi-scanning capabilities, which actually just explained, put together create this domain, this perimeter defense capabilities, which is a formidable obstacle for malicious attackers. This is a cloud-based architecture, which means that it's highly scalable with multiple deployment options based on requirements and different API feeds and pipelines, as well as potential integration into direct ICAP server network traffic. So I'll go over the deployment in the next slide, please, Stuart. So this slide demonstrates a basic overview, a high-level overview about the sort of deployment of Halo into the cloud architecture. So this is Kubernetes deployment, which, as you can imagine, allows for a high scalability with several different APIs. So there's both synchronous and asynchronous APIs, which allows for both sort of linear processing and asynchronous processing based on the sort of volume that you're processing and the requirements for throughput from the individual feeds. All the processes would either come through a client-side application, there's a web interface as well, or this can be put directly into your pipeline via the API calls, and this can be linked directly to your ICAP server, as mentioned before, for network traffic as it is incoming. As part of the process, it goes through the CDR embedded engine, which is the Glasswall's CDR processing, as well as going through the ReversingLabs for our reputation analysis, which was outlined, which generates a analysis report and feedback, which allows you to decide on how that file is going to behave based on that, and you can actually control the pipeline accordingly. So the output will be the original file, which will be what was coming in from the external source, the rebuilt file through the CDR process based on your policy, and the file reputation that ReversingLabs provide, and an overall analysis report of what was done to that file and what the statistical analysis of that file, both ReversingLabs and CDR, produced. There's also metrics which are generated, which we'll go over shortly, which can actually generate a global report of what is currently being processed.
Very interesting.
So at a high level, this is the operational throughput. So from the left, the unknown file is put through to the Glasswall Halo system. The file is automatically submitted to ReversingLabs file analysis, which provides a reputational score of, again, benign to suspicious or malicious. Based on your profile or client profile specifications, that file is then CDR'd or automatically quarantined. The CDR process based on the file, or actually irrelevant of the file, only based on the client policy, the file is then CDR'd. So again, we go through that clean, that validation and the content removal based on your risk tolerance. And then the file is either quarantined or discarded based on whether it's severely malformed, or the cleaned and sanitized file is provided to the end user. But I think we'll go into a bit more detail on the ReversingLabs section here. So I will hand off to Ashley.
Sure thing. So I think the critical thing here with ReversingLabs is, as Connor mentioned, we provide a file disposition. And so Stuart mentioned earlier, we were talking about the paradox between the time that is needed and the cost associated with this zero trust model of really needing to examine every file that goes through a system. The scale of that, I think, for most organizations at this point is enormous, and there isn't enough money or security engineers in the world to really effectively do that without very good tools. And even with good tools, maybe not still the case. And so we're wanting to sort of mitigate the strain that this puts on an organization. And so what we're really seeking to do here is to triage using the quickest and least expensive methods. And so the way that this happens is really going to depend on your triage strategy and the policy that you choose to enforce. So you are going to need to consider, do you want to CDR files that are potentially containing malware? Do you want to proactively quarantine them? What is your approach? What is your tolerance for latency or lag time? And so the Halo system here really allows our customers and people who are able to enable this system to maintain the speed that CDR enables. There isn't really latency or lag time to be experienced. So if you need to maintain uptime and not have your users notice any sort of delay, then that allows you to do so. But then with the ReversingLabs component, you're also able to dig in and see, how are you introducing risk into your system, and what are you able to glean to really develop detection or hunting rules or whatever it is that you're intending to glean from more detailed file analysis. And so the combination of the two is really seeking to optimize your triage strategy. And so that would be both from a cost and time perspective. Stuart, if you could go to the next slide, and I think I've actually just about covered everything that I have on this slide, so we can go to the next one as well, and I'll hand back to Connor.
Okay. Yeah, I think it's just coming back to the one point, right? Do I really want to CDR a file that I know is a malicious executable, right? I mean, why not strip that off now and then have CDR focus on the things that it really should be focused on? And that way, you know, again, reducing the time to respond. Okay. All right.
Brilliant. So thanks, Stuart. Thank you, Ashley. So this is the demonstration of the report that Hello actually demonstrates through its web user interface. So I'll quickly just go through what this is displaying, and then we'll actually go through some examples in more detail. So here we have three primary sections here of original file risk, original file malware status, and then at the bottom here we actually have what was removed as part of the policy settings from that file during the CDR process. So in this example, the top one says that the original risk level based on the contents of that file was considered to be medium. But as we can see from the malware status, this was actually deemed to be malicious by the file reputation analysis. And then at the bottom there, you can see that both embedded images and internal scripts were removed. So this is just a dummy file to show the sort of reporting that we would be dealing with. But now we're going to go over some real samples, which we put through the Halo system to demonstrate the sort of output you could expect.
Yeah, I really like how this is well representative because, you know, I'm an operator. I'm looking at 1,000 of these a day that, you know, pops up and has a little red bug with the 5 next to it. Makes my life a lot easier, especially when I'm on my 3rd pot of coffee today and things like that. So, you know, I really think this is really well presented.
So one of the other key things there is that it actually has the threat name. So again, WannaCry, as we all know, is a very prolific malware type, and that this report, when ReversingLabs provides that feedback, can give you a very quick overview of the type of malware that you could potentially be dealing with. And again, depending on where this was originating from, it can actually give you some really good threat intelligence about, you know, where threat actors are operating from or where they may potentially be targeting. So it's all really valuable information. So this is the global reporting page, as I said earlier. So this actually comes down to the statistics. So the top two pie charts there are actually demonstrating the Glasswall throughput. So this is the CDR processing. So on the left, you actually have the original file risk. So this is how the contents of files are being determined across the CDR processing. So from high risk to medium risk to low risk, as we just demonstrated with the dial in the previous page. And on the right there, you have the file protection level that's being applied. So in green, you have fully protected, and then policy protected, which is where the file is only being processed on certain components based on the client's policy. Blocked means that you've actually specified some controls of if these elements exist, do not allow the file into our estate. And finally, the smaller section is the unprocessed, which will be files which are considered to be so malformed that they cannot be repaired and cannot be returned. At the bottom there, you have ReversingLabs statistics, which we get through from the Halo system as well. So this is to demonstrate the types of files and how they've been classified. So you get a really quick overview of the types of files that are coming through and how they're being processed through the Halo system. So you get that really quick snapshot, really useful information of the types of threats that you may potentially be dealing with, as well as on the right, the severity of the malicious file itself. So again, classifications based on the types of threat actors, types of malware, which are being classified by ReversingLabs advanced file reputational analysis. So this just gives you that one-stop shop for the types of statistics you'll be dealing with on your estate.
Thank you.
So we'll go through some real samples here. So these were 3 samples on the left, which we're putting to a zip file, so a compressed archive file, and then submitted to Halo. On the left, you can see that there's 3 files, a docx, a PDF, and the top one is actually a binary file. And the first file we're going to look at is Nothing Fun, which is a Word document OOXML. So this was just a randomized file which I generated. This had no patented technology. The metadata was just a bunch of nonsense, and it had no particular malicious nature to it whatsoever. And as you can see from the Glasswall risk assessment, this is actually considered to be medium. And the reason for this is that it contained metadata and an image, which, although not by themselves, is considered to be, a malicious action that could be used to store some malicious actions, or it could be used to have covert communications, as we mentioned earlier, potentially within images. So the Glasswall CDR process here is considered to be protected by policy because we only process certain elements. We didn't process metadata in this example, but the images we did remove. So this would be considered to be protected by the client's based policy of how they want that to be handled in that particular domain. I'll ask Ashley to explain the RO reputation to do with this particular file.
Yeah, pretty straightforward here. Connor mentioned he generated this file, and ReversingLabs does not recognize this file because it hasn't been seen before. Connor has not submitted it before. So, in this case, pretty self-explanatory.
Thanks, Ashley. So if we move on to the next file, Stuart. So this one is slightly different. So this PDF file was actually using an external link, which is to do with a potential NTLM credential leak. And the reason this was considered high is because it uses an external link as well as an embedded auto trigger link in order to perform that action. So the Glasswall assessment for this was considered high, but again, the protection policy was there as well, and these active links, the external links and the open action were automatically removed as part of the CDR processing. However, this was only to perform an external link to an SMB server in order to perform that NTLM leak. So although the use of both an open action and external link can be considered risky, it's not necessarily going to be something which can be considered malicious by itself. And again, I'll ask Ashley just to weigh in on the file reputation here.
Yeah, so like Connor mentioned, and this is a really common tactic used by threat actors to fly under the radar. Oftentimes benign actions or actions that are not innately malicious of themselves are used to conduct malicious activity. And so we're not able to classify those things as being malicious unless you want to block all activity reaching out to external links. And that obviously is not something that you're likely going to want to do as an organization. And so in this case, despite the behavior being used for malicious means in this example, we're not able to categorize this as malicious. And so the reputation you see here is benign.
Yeah, that actually brings up a good point, actually. I mean, if I send you a doc that has nothing malicious in it, but there's a link in there to a malicious website, is that benign or is that malicious? I know I've had this conversation with a lot of people, in a discussion about, should we mark that as dangerous and say, well, it's not dangerous unless you click on it, right? And so the question becomes, how do you want to classify, or do you just say any document that has a link in it, we're going to block that, and then 20 minutes later, your boss tells you to stop doing that because everybody's complaining, and then turn it back on, turn it off. So I think it's going to, again, there's behaviors, but they have to be associated with malicious activity, right? Reaching out to a website to get what the weather is not a malicious activity. It's just what it is. So again, it becomes a real challenge to a lot of organizations to decide how to deal with these types of things. And I think this is where, file reputation and CDR combined can really add some real strength,
100%, Stuart. But again, a lot of this comes down to the sort of risk tolerance you have with where those files are going. So when it comes down to your general user, I think that's absolutely the case. But when you start to deal with critical, sectors within your industry, having any link may be potentially a risk. And obviously, this is where that CDR filtering for these types of content really shine.
Yeah, it's like when you go to the meeting and they make you put your phone in a little bag and
Exactly.
take off your smartwatch before you go in and talk to them. Then you know what kind of tolerance they're looking at. Okay. So
So
we're going to go ahead and look at the third thing, which again is a file that's been identified by ReversingLabs as malicious. So here we have an executable file. We've examined this. We've either seen it before or we've used section hashing to uncover the characteristics of the file. And then we're usually able to uncover what kind of malware it is. In this case, we're looking at a Janella wrap binary. I'm saying that right. And again, being able to look at reputation. So putting the reputation in as malicious, we're able to see that. And Ashley, do you have a comment on this?
Yeah, this is another one that I think is pretty self-explanatory. In this case, it's just objectively malicious behavior. There's not really any behavior within this file that could be used in a benign way, or at least it would be very unusual to be used in a benign way. And so we're able to just call it malicious without really much nuance there.
Right. It's like when the cheese has all covered in mold, right? You're like,
Right.
well, do I really want to pick the mold off, or you know what, we'll just throw this away. So I think, and again, it's the ability to see, thousands of different file types and be able to pull them off very quickly. And it, being able to go through and do that, complements the Halo solution. And, being fully integrated, I think it just, dramatically reduces the amount of time that it takes to, process these files and get a result. So we're going to talk about how Halo fits into security architecture. And I think this, and with ReversingLabs. Connor, if you want to start off.
Uh, yep, sure. So again, so when it comes down to the how it fits in security architecture, because it's zero trust, one of the primary things is to do with domain boundaries. So this always comes back to, again, focusing on perimeter defense, but whether this is to do with the estate's perimeter or to do with the siloed segments within your own estate, that's where Halo really shines. That's where it really holds and has its core value. So whereas it excels at mitigating threat actors that are used for like initial compromise, as we mentioned before, it's also really good at addressing those sort of potential internal threats or post exploitation where you have compromised accounts potentially moving between different domains as well. With the structural compliance, you have that high level of mitigation whilst also maintaining the utility of the files. When with the addition of the reversing labs and file analysis being tied into that entire process, you have this inherent security provided by the zero trust CDR process, whilst having the threat intelligence provided by reversing labs to accurately identify any known threat, any granular threat, any section of files which could potentially be malicious. So you're getting this sort of control over all the perimeter, both from the external to the internal, but equally between internal components against what can be potentially a risk, but equally what is known to be a threat. And that is one of the key focuses here, and that's where it really sits within the security architecture in those boundaries between those different risk tolerance sections.
And actually, we know we talk about, and ReversingLabs, we always talk about like zero trust with like never trust, always verify, right? So again, being able to establish a verdict on a file, it's either a good file or it's a bad file. There's really, that's what you're really looking for. How do you see ReversingLabs fitting, in a zero trust architecture in this type of environment?
Yeah, I think when I picture the system, I like to think of a flow chart where we're trying to reduce that flow as much as possible. And so wherever we're able to divert a file out of this process and maintain that quickness that we're looking for with triage strategy, we want to do so. So if we're able to analyze a file really quickly, return a malicious verdict, we don't need to get into those complex levels of analysis that we discussed earlier, unless there's really a need to dive deeper. And so what we're looking to do here is continue to really take a look at any sort of nuance, that less than 1%, where we would send those files to the sandbox. And so in those cases, ReversingLabs is able to provide a really detailed report, in the instance that you are looking to hunt for threat actors in your system and identify, where they otherwise might be hiding, if there is a particularly clever or hidden methodology that's being used, and that's another area where ReversingLabs shines. But again, the goal is to not have to go to those depths in terms of analysis unless it's necessary because of the manpower and the cost associated with doing those kinds of investigations.
Okay, this sounds great. Thank you. So again, mitigating threats as they enter a state or cross the domain boundaries. Okay. So we're going to go ahead and talk about Earth Kasha, and this again is a relatively recent attack, and we think we should be able to go and talk about this.
Thanks, Stuart. So Earth Kasha, so this original report was actually done by the guys over at Trend Micro, Harai Hiroaki. I do strongly recommend you read their report. It's extremely detailed, and it's where we obviously got the information based on related to this attack campaign. So this is a threat actor group which specifically targets Japanese business interests, and this campaign itself was actually detected in June 2024 using the Anel backdoor agent, though this was actually previously associated with the state actor APT-10 from China back in 2018, as well as Earth Kasha using the Nuke backdoor agent as well. So APT-10 have actually been known to use both. So there's a argument whether Earth Kasha is affiliated with the APT-10 state actor. This is not officially confirmed, but there is a strong relation between the two actor groups. And equally, they do use extremely highly capable agents and techniques in order to affect their targets. So if we look at a timeline of the Earth Kasha campaigns since 2017, you can see that since 2017, 2019, 2023, and 2024, the agents that they've used, which are boxed, again, you have NL, load info, and nuke and then in the text underneath, you have their initial infection vectors that they've used, and you can see that 3 out of 4 times they've actually used spear phishing campaigns with file delivery as their initial infection vector, which has been extremely successful. So if you go to the next slide and we just look at where Glasswall CDR would focus and really be the most effective and mitigating these sort of campaigns, it would be actually affecting the spear phishing. So again, when you have those files which are targeted at particular individuals using advanced capabilities, this is where the CDR technology, because regardless of their origin, which is obviously where spear phishing can socially engineer, that those files would be automatically processed and sanitized and cleaned based on the client policy. And I'll just hand over to Ashley to go over, again, ReversingLabs coverage.
Yeah, so you can see here that ReversingLabs is able to analyze the files that are used in this campaign at all stages of this attack. But I think where we really shine is being able to analyze files that are associated with the events in 2023, where spear phishing wasn't the campaign that was used as an initial vector. Rather, we have potentially obscure file types, very large files, things that maybe aren't the best fit for a CDR solution. And so in that case, ReversingLabs, I think, really shines here. In the areas where Glasswall shines, which is the majority of this campaign, where they're using spear phishing techniques, we're able to provide a little bit more file enrichment. So when paired with that Glasswall solution, we're really able to provide a comprehensive view of what's going on with this campaign.
Yeah, and thank you, Ashley. I think that's a really good point because you have that continual feedback loop, right? You have spear phishing, and so it's being detected. We're uncovering files within the spear phishing. They may be files that have never been seen before, but then we add them back in. Now we've seen them, so now everybody becomes aware of them. At the same time, the organizations, the threat hunters, the threat intelligence compliance people are starting to see what type of attacks they're being being subject to, and be able to do that. At the same time, Glasswall is able to better process these files because, again, we're stripping off 90% of the bad files. So, that have already been seen, that don't need to be CDR'd or don't, doesn't make sense to CDR them. And so in that case, the operators are able to really focus on the problems, and again, a lot of people who are watching this right now know exactly what it means to come in the morning and see 2,300 open incidents, right? And think, I got a meeting at lunchtime. Well, how am I going to get this done? So again, being able to strip these out, automate this, but also provide that constant feedback loop and the ability to see files that look like sort of other files. And, to say, something we're doing with our section hashing and being able to pull that out is, again, I think a real strong ability here. Okay. So Connor, if you could give us a little bit more technical detail.
Sure, Stuart. So looking primarily at the spear phishing, so again, from a Glasswall perspective, this is to do with the deployment that they were using in the 2024 campaign. Their initial infection vector using spear phishing was either sent from free accounts or by compromised business accounts or BECs. And from this, they actually deployed it in three different ways, so three different use cases. So you had a direct docm, so macro-enabled Office document, which would download a zip file, which would then be extracted and then sideload the NL binary payload, or the NL binary payload would be stored within the docm. It would automatically extract itself and then sideload. The other two both originated with LNK files, the first of which would then use an SFX to download a .m or template macro-enabled file, which would then download a zip and perform the NL. Or the final we would use the LNK, which would have embedded PowerShell to, again, zip file, .m, and then it would zip again, pull down a secondary zip file, and then do the NL sideloading. But the macro that was used in all cases by Earth Kasha. So the guys over at Trend Micro actually labeled this as something called roaming mouse. So this is an advanced capable VBA macro payload, which had sandbox evasion. It would actually perform mouse checks. So a mouse would have to move over the document over certain sections of the document. Otherwise, it wouldn't enable itself. So this avoids some standard sandboxing techniques. It also used custom base64 encoding tables. So base64 basic decoding would fail, so you wouldn't necessarily be able to pull up the payload. Some of the more rudimentary methods were just hex-based payloads, which obviously we would be able to pull out in an automated fashion. But equally, from a behavioral perspective, they actually actively avoided native binary executions using things like CMD or PowerShell, and instead used WMI leverage to pull down and execute binaries in order to perform the sideloading. In this case, they actually used scan configuration 32. So this is actually a McAfee capable binary, which actually enabled the sideloading capability of the malicious DLL file. So in all cases, they were using this advanced VBA payload inside a macro-enabled document file to affect the dropper here.
Okay. Now, was this a new dropper or was it they were using technology?
So going by the Trend Micro report, this was actually completely customized for this particular campaign. And again, the ways that they were using it and the particular structure of it was something that was only attributed to this campaign.
It's interesting you say that because Ashley and I, we spend a lot of time talking to, chief security officers and government people and the thing that really, concerns them are these sort of targeted campaigns, right? It's not, just a spray where they've got some old malware that they bought on the dark web and they're just blasting out there. It's where there's a brand new campaign, it's a brand new target, it's, very much targeted to the individuals. And those are the ones I think that organizations it's the hardest to defend against. I mean, what do you think, Ashley?
Yeah, I think I'd agree. It is really tricky to defend against something that's completely tailored to your organization. But I think those vectors are also generally quite successful for threat actors. And so that's why the time and effort is put into developing those attacks. And so to detect those sorts of vectors, you have to use a solution that's a bit more sophisticated. And so in that case, I think something like Halo really shines.
Yeah, and I think it's, the analogy of like locking your car door, right? It's not that you're going to prevent every car theft. It's basically that car thieves are lazy and they're just going to go somewhere else. So they're just walking through the parking lot trying car doors or
Also
through the
true.
neighborhood. Whereas, if you defend yourself, if you do provide an active defense, not only you're much more less likely to be attacked, but at the same time, when you are attacked, they'll just go somewhere else after a while. They get frustrated and leave. I mean, they're not hardworking, they're criminals, Yeah. So, Connor, can you go through this on BBA?
Yeah, absolutely. So, looking at the Trend Micro report, we actually extrapolated some of the VBA capabilities that they highlighted and created a docm file and .m file that emulated those capabilities. So here we have some of the sandbox checks which were put into this file, as well as obfuscated payloads, which would ultimately result in the same type of execution using WMI leveraging. But I think this one was instead just to perform standard, calc.exe, but we're still using the same control flow in order to emulate the sort of attack vector that they'd be using here. So we wanted to create a file which we could test through Halo to emulate what would happen to a file using the same capabilities.
Yeah, it's interesting. I mean, when you study criminal, these hacker groups and things like that, very often there are individuals who have, I'm going to create the dropper, I'm going to create the loader, I'm going to create the sandbox evasion tools, and those groups share information and, basically, or there's one supplier who supplies a whole bunch of different groups, and we see sandbox evasion being a very big area. And that's why it's sort of important to us that you don't have to send 30, 45%, 50% of your files to the sandbox. Because again, people are actively trying to avoid these things. Okay. So Ashley, if you could comment on this, please.
Yeah, definitely. So what we're looking at here is the Glasswall Halo view of the file that Connor was just speaking about. And so you can see here that Glasswall correctly assessed this as being of high risk. And so in this case, protected by CDR policy. You can also see the different ways that Glasswall was able to clean this file. And so in this case, this doesn't exist in our reputation database at ReversingLabs, but Glasswall was able to successfully grab this file and strip out the malicious activity before it could cause an issue in the environment.
And then, once that file has been seen, then we do know about it, right? And then that fits into, then all of a sudden we are able to process it, and then we're also able to see the characteristics of the file. Okay. And Connor, you could share this.
Sure. So again, as an example of this, we actually pulled down the cleaned file from Halo and we ran it through Decalage's OLE tools. So the OLE tool sets developed by Decalage is a very well-known analysis tools used for OLE documents. And one of the things it can do is actually extract the VBA streams from documents and display them for analysis. And what that image there shows is that the cleaned file has no VBA content whatsoever. So part of the CDR process based on policy was to remove VBA scripting, VBA streams, which has been performed based on the analysis through the OLE toolset. But one of the questions we then asked was, well, instead of using a docm, what if they use the same capabilities within a PDF? So we decided, and the bottom image, which I appreciate, is quite small. So I'll quickly go over the content in general. So we used the same case as case one, which was before. So what happens here is the PDF document actually has the binary payload, which we embedded we put it in as an embedded file. And then what happens is on document open, it will automatically run a dropper. So it would extract the binary file into a local file space, and then it will use a automatic execute in order to trigger that file. Now, to do this, we used elements from well-known malware capabilities. So we actually used a very standardized sort of capability in order to perform this sort of dropping activity through the open actions of PDFs. So if we go to the next slide, you can see through Halo here, we have both the Glasswall CDR risk assessment being high, but also the ReversingLabs for our reputation also accurately confirming this as being fully malicious. So from a CDR perspective, the risk is obviously highlighted as high due to the open action, the execution and file output. And you can see in the bottom right there that the JavaScript and the embedded file have automatically been removed as part of the CDR process. But I'll just quickly hand over to Ashley to explain how, in this case, obviously the content has been analyzed by by ReversingLabs.
Sure. So as Connor mentioned, these are known tactics that are used by malware actors. And so in this case, because we're able to analyze the file by sections, Reversing Labs also returns this as malicious. If we could flip to the next slide.
Yep.
And so when we look specifically just at that binary that was embedded as a payload, in this case, this isn't a supported file type for Glasswall, but for Reversing Labs, we are able to analyze that component and able to provide that file reputation as being malicious. And so, in the case where, for whatever reason, CDR is not going to provide analysis, then Reversing Labs is able to provide disposition in that case. And so you can see here, the solutions pair really well together to provide this comprehensive view of a potential campaign.
Right, and you can strip these files out, quarantine them without having, without clogging your essential services. Yeah. Okay. So, again, I think, what we've tried to present today is the idea that, CDR, very powerful technology, works very well, especially in unknown files, targeted files, document files. Reversing Labs has the ability to see thousands of different types of files, has hundreds of billions of files recorded, and we're able to see them. So we're able to, bring these two together. So I think, talking about that and being able to have it integrated into a single solution and then being able to tie it together very, very quickly, I think it shows a tremendous advantage to customers. And again, combination of the two creates a standard, pretty formidable defense, being able to handle traditional attacks very quickly, and then to be able to handle new and targeted attacks. And again, freeing up the time of your operators to be able to deal with target attacks. But also you have operator fatigue, right? If I come in every day and I see 2,300 alerts or incidents, and 98% of them are just exactly the same thing where I'm just clicking and clicking and clicking and clicking and clicking. Again, I just get bored and tired and frustrated, and it doesn't help our organization. And automating, being able to tie these two together, I think is a very powerful solution. Again, we have the strengths of Glasswall, and they're, much better than normal CDR technology. And you have Reversing Labs, which has a much better than normal file reputation solution. So again, combining the two together, I think you can create a very powerful solution. Hey, Connor or Ashley, do you have any comments at the last?
So from my perspective, again, completely agree. And effectively, these two technologies combined in Halo create this sort of stacked layer of defense that just creates this absolutely daunting sort of task for any sort of threat actor to think about trying to overcome that, both with the advanced file reputation technology and the inherent zero trust sanitization and verification of the files. You stack those two together, and effectively, standard and classic attacks don't really stand much of a chance, and only the most dedicated attackers would even consider trying to overcome that. And even then, they're going to have a hell of a job trying to get past that sort of collaborative technology.
Well, thank you. And Ashley, do you have anything to comment at this point?
No, I think Connor just about summed it up.
Okay. So I'm going to go ahead and turn this over to questions. We have a few questions in the chat, and I think we can talk about. So what are the latency considerations in the phases of CDR?
So CDR, I suppose, do you mean between the, extracting the question, would that be between the validation and the rebuilding and cleaning sections? So the files typically process in under a second. Obviously, it is entirely dependent on the file size, but they are processed extremely quickly. So it tends to work in sequence and at extremely high speeds. But again, one of the things for Halo is one of the API capabilities that we have is both the synchronous and asynchronous APIs. So depending on the types of files or the volumes of files that you're dealing with, you can submit to an asynchronous API call so that files are processed with effectively a sort of callback system, so that once they are processed, they can be fed back into your pipeline without the user having to wait on the response.
Okay. Is Halo on premise or cloud, or how can I, you said it's Kubernetes, can I deploy it on premise?
Yes.
Okay, great. How do you remove files with detected malware?
So again, so this comes back to the idea of client-side policy. So depending on the client's preference, files can be CDR'd whether they're considered malicious or not. But equally, depending on ReversingLabs' reputation, which is provided before the CDR process, the file can be automatically quarantined, or as I said before, it can be put through the CDR process based on clients' preferences. So it depends. Again, you can also do this based on the ReversingLabs score. So again, if you have something like a 5 out of 5, which we consider to be absolutely malicious, you may want to block that. Whereas if it's only considered to be suspicious, you may instead want to put that through the CDR process. And again, that's typically based on risk tolerance.
Mhm. And the question, do we foresee using signature analysis before or after, or both CDR has been performed on the file?
So this is currently being performed before the CDR process, and again, it allows for that sort of granular control over the sort of how that file is then processed based on the file reputation that ReversingLabs is providing.
Okay. And after the file has been marked bad by Glasswall, then that's updated in ReversingLabs. So now we know about it. Yeah. So no, that was a statement more than a question. Sorry. I have a little bit of a cold, so my voice is going up and down. So I apologize for that. But I'm just
Sure.
saying, once we've seen the file and it's been marked, we've taken the source of Glasswall or other sources to say, somebody marked this as bad already, then we take the file in afterwards, so that works well with files that have never been seen before. Okay. So I think that's all the questions we have. If there's any more questions, please put them in the Q&A. I also like to put up, we have some additional resources here. Again, we have an online blog which will cover this in detail. We have an interesting case study talking about using Spectre Intelligence in your MSP or MSSP, and again, SOC optimization. But due to the size of, question, due to the size of ReversingLabs reputation database, does this impact the size of Halo? Will there be options for this, or is it all or nothing? That I do not know the answer to. Do you know the answer to the one that was?
No, I'm afraid off the top of my head, I don't have an answer to that. However, if you do email me, I will be sure to get an answer for you.
Okay.
So that just to clarify, that's at cmorley@glasswall.com. Sorry, cmorley@glasswall.com.
That's good. All right, we'll try and get you an answer for that. Okay, I think we are done. We had a great time. Again, these are the emails. If you have questions, I'll be very happy to answer your questions. But I think I've been extremely happy to meet your acquaintance, Connor, and get a chance to talk some more, and especially learn more about CDR and how we're working together. And Ashley, always a pleasure. It's just it's always good to be in a room with someone much smarter than you. You know. Anyway, all right, and I think at this point we're going to go ahead and stop. So thank you very much.
Thanks, everyone.
Fun.